I'm Anil Kumar. In this particular video, we'll discuss how to prove trigonometric identities. So I've taken a few examples which are relatively simple. I'm calling them level 1. We'll use basic formulas to prove these trigonometric identities and understand the concept. So here are 8 questions which I'm going to do in this particular video. Now the formulas which you may need to prove these identities are like this. You could write tan theta as the ratio of sine and cosine. So that could be written as sine theta over cos theta. Then we are using the reciprocal angles here. For example, we are saying cot theta is 1 over tan theta, as you know, right? And reciprocal of sine is cosecant theta, which is 1 over sine theta. We'll use reciprocal of cos, which is secant theta, which could be written as 1 over cos theta. You will be also using Pythagorean trigonometric identities, which are like sine square theta plus cos square theta equals to 1. Then we have 1 plus tan square theta equals to secant square theta, and 1 plus cot square theta equals to cosecant square theta, right? Now these formulas can be written or arranged in different ways. For example, instead of 1 you can write sine square theta plus cos square theta. You would also use formula like sine square theta is equals to 1 minus cosine square theta, that is taking cosine on the right side, or you can say, well, cos square theta is equals to 1 minus sine square theta, correct? So these will help you to solve all these questions. So I hope that is good. You can pause the video, copy these questions, try them out, and then look into my solutions. So let's begin one by one. Let us start with the very first question, which is sine theta plus cot theta equals to cos theta. Now to prove identities, we call this side as the left side and this is the right side, right? So the idea is to start from one side and prove the other one. So we'll say let's start with the left hand side. So left side is given to us as sine theta times cotangent theta, right? Cot theta can be written as reciprocal of tan theta. So we could write this as sine theta times 1 over tan theta. Now, as you know, tan theta is sine over cos. So we'll rewrite this as sine theta times tan theta is sine theta divided by cos theta. So I can take that cos theta on the numerator side. Now we can cancel sine and sine, and what we are left with is cosine, correct? So what you get here is cos of theta, and that is right side. So that is how we start with left side and prove that that is equal to right side. And then we say since left side equals to right side, we have proved this identity. So these are simple steps to take to prove this identity or such identities, right? Now let's do the next one. So in this particular exercise, what you saw here is that we are going to replace tan theta by ratio of sine and cosine, correct? And reciprocal ratio for tan. Now again we have tan theta. We'll replace this tan theta on the left side. So we'll start with the left side again. It seems to be more complicated. It can be simplified. That's the reason we are starting with left side. So we'll write sine and cosine as such. Strategy normally is to write everything in terms of sine and cosine. So tan in terms of sine and cosine will be sine theta over cos theta. Now in this, you can cancel cosine and cosine, and what you get here is equal to 1 minus sine square theta, right? 1 minus sine square theta. And as you know, 1 minus sine square theta is cos square theta, right? So this is equals to right side. So here we use the Pythagorean identity sine square theta plus cos square theta equals to 1, we kind of rearranged it, right? So we say cos square theta equals to 1 minus sine square theta. So that is what we used here and got our result. So I hope the steps are clear. Now let us prove the identity sine theta plus tan theta divided by 1 plus cos theta equals to tan theta. Since left side is more complicated, we'll begin with the left side. Let's copy the question first. It is sine theta plus tan theta divided by 1 plus cos theta. Now first step is to write tan theta as sine and cosine, right? So we could write this as sine theta plus tan is sine theta over cosine theta, and we have 1 plus cos theta in the denominator. Now we can take a common denominator of cosine theta in the numerator, and we get sine theta cos theta plus sine theta. In the denominator, we have 1 plus cos theta. Now we can take sine theta common, right? So taking sine theta common, we get the term cos theta plus 1, right? We have 1 plus cos theta in the denominator also. That will now cancel, right? This cos theta comes in the denominator, so we have cos theta times 1 plus cos theta, correct? Now cos theta plus 1 and 1 plus cos theta cancel out. What do we get? We get sine theta over cosine theta, and that is indeed equals to tan theta, correct? Which is the right side. So we began with left side and got the right side. That is how we prove the identity. The only strategy which we have applied here is to write tan as ratio of sine and cosine. Perfect. The last question here is 1 plus tan theta divided by secant theta equals to sine theta plus cosine theta. So let's again start with the left side, which is 1 plus tan theta divided by secant theta. Since we need to write in sine and cosine, it makes sense to write tan theta as a ratio of sine theta and cos theta, and secant theta as 1 plus cos theta, correct? So that is a good strategy to do. Now we can also do one thing, that is secant theta can be written as 1 over cos theta, right? So see how we can rewrite the left side as. So we have this as 1 plus tan theta is sine theta over cosine theta, right? And in the denominator, we have secant theta. So that really means that we are multiplying this by cos theta over 1, correct? Because secant theta is 1 over cos theta. So 1 divided by cos theta means you multiply by cos theta. Does it make sense? Correct? Now you can open the bracket, applying the distributive property, right? So when you open the bracket, cos theta will get multiplied with 1 and with this term. And what do you get? Cos theta times 1 is cosine theta, plus here you get sine theta times cos theta divided by cos theta, right? Cos theta and cos theta cancel. So you get your right side, which is equal to sine theta plus cos theta, correct? So basically I interchanged it. You could have written cos theta plus sine theta and then that, right? Which is equal to the right side, correct? So as you have seen here also, proving trigonometric identities to begin with is not difficult. Now let's do the next question. I hope you are enjoying the journey of learning how to prove trigonometric identities. Now we are getting into slightly difficult portion of trigonometric identities, still at level 1. We need to prove cos to the power of 4x minus sine to the power of 4x equals to 1 minus 2 sine square x. Now in this case, we can use the formula a square minus b square is equal to a plus b times a minus b, right? So difference of squares is product of sum and difference. Now this particular formula is used many times whenever you see exponents in trigonometric identities. So let's begin with the left side again. Rewrite what is given to us, cos to the power of 4x minus sine to the power of 4x, right? I could write this as cos square x whole square minus sine square x whole square, correct? Now we'll apply this formula. A square minus b square is a plus b times a minus b. So a for us is cos square x, right? So we'll sum of these two, which is cos square x plus sine square x, times difference of these two, which is cos square x minus sine square x, correct? Now what is cos square x plus sine square x? That's a Pythagorean identity. You know, cos square x plus sine square x is equal to 1. So this portion is 1, right? So we get 1 times cos square x minus sine square x, correct? We need 2 sine square x. So what can we do? We can rearrange this and write cos square x as, we could write this as cos square x is equals to 1 minus sine square x. Do you get the idea, right? So I'll replace this cos square x with 1 minus sine square x. So 1 times anything is that thing only. So cos square x replaced by 1 minus sine square x. First term becomes 1 minus sine square x, and we already have minus sine square x. Combining these two, we get 1 minus 2 sine square x, which is the right side, correct? So we have proved that left side is equals to right side. So I hope this strategy is straightforward. So this time we have applied Pythagorean trigonometric identity to prove the trigonometric identity. The next question here is product of sine theta plus cos theta with tan theta and cot theta. We want secant and cosecant theta. Let's begin with the left side. Here we have sine theta plus cos theta times tan theta plus cot theta. Now you can actually pause the video, answer the question, and then look into the suggestions. What should be your first strategy? Write tan and cotangent in sine and cosine, right? So that's what we are going to do. So we have sine theta plus cos theta times, this can be written as sine theta over cos theta. Cot is cos theta over sine theta, right? Now we can take common denominator. We have sine theta plus cos theta as the first factor. Here, if I take common denominator as cos theta sine theta, they get multiplied. I get sine square theta plus cos square theta, right? And you know sine square theta plus cos square theta is 1. So we get sine theta plus cos theta times 1 over sine theta cos theta, correct? Since we know that sine square theta plus cos square theta equals to 1, right? So we replace this with 1. Now we can open the bracket. So we get sine theta divided by sine theta cosine theta plus cos theta divided by sine theta cosine theta, correct? So we can simplify by cancelling the common terms in numerator and denominator, getting the result 1 over cos theta plus 1 over sine theta. And what is that equal to? 1 over cos theta is secant theta and 1 over sine theta is cosecant theta. This is what we wanted. That is the right side, correct? So that is how you could prove this particular identity also. So I hope you are enjoying the whole process. It is not all that difficult and requires some strategies. We'll learn another strategy now when we prove cos x over 1 plus sin x plus cos x over 1 minus sin x. So let's again begin with the left side, which is cos x over 1 plus sin x plus cos x over 1 minus sin x. Correct. Now cos x is common. I could take this outside. So we can say cos x, and what we get here is 1 over 1 plus sin x plus 1 over 1 minus sin x. Correct? Let's take common denominator, which is product of these two, right? So let me write this as 1 plus sin x times 1 minus sin x for the time being. Cross multiply. We get 1 minus sin x plus 1 plus sin x. Correct? Now we get cos x times, the numerator becomes 1 plus 1 as 2, minus sin x plus sin x is 0. In the denominator, a plus b times a minus b is what? A square minus b square, correct? So a square means 1 minus sine square x. That's what we get. Now let's further simplify the expression on the right side. We can now write this as cos x, we're talking about left side only, cos x times 2 over 1 minus sine square x is what? 1 minus sine square x is cos square x, correct? Yes, you know, cos square x plus sine square x is equal to 1. So you could write cos square x as 1 minus sine square x. So replace this with cos square x. Once you do that, you can simplify by crossing out common factors from numerator and denominator. So you get 2 over cos x, which is 2 secant x, which is the right side, right? So we have again proved left side is equal to right side. So in this case, we applied the Pythagorean identity. Let's move on to the next question, and this is the last question of our level 1 trigonometric identities. Here on the left side seems to be more complicated. We have square root of 1 minus cos x over 1 plus cos x. Now whenever you see square roots, then rationalization is a good option. So the conjugate of 1 plus cos x is 1 minus cos x. So we'll rationalize denominator. So rationalization of denominator. That's what we are going to do to prove this particular identity. You can actually pause the video, answer the question, and then look into my suggestions. Let's see how to do rationalization. I could write this as 1 minus cos x within square root over 1 plus cos x within square root. Rationalization means we'll multiply this by 1 minus cos x, which is conjugate of denominator, over 1 minus cos x, correct? Now what is 1 minus cos x square root times 1 minus cos x square root? It is just 1 minus cos x, correct? In the denominator, we get within the square root 1 minus cos square x, right? A plus b times a minus b. So that gives us 1 minus cos x over square root of 1 minus cos square x is sine square x, right? So you have seen this identity so many times being applied. So we know cos square x plus sine square x is equals to 1. So we have been writing sine square x as 1 minus cos square x, correct? So let's solve it further on the right side. Let me continue here. What we get on the left side is 1 minus cos x, and within square root it is sine square x, so we get sine x. So I could write this as 1 over sine x minus cos x over sine x, correct? 1 minus sine x is cosecant x, and cos over sine is cotangent x, and that is the right side. Do you see that? So that is how you could easily solve or prove this particular identity. So rationalization is a good method to do whenever square roots are involved. So I hope you learned very important strategies in proving these trigonometric identities. Feel free to like or subscribe my videos, share your comments and views. Thanks for watching and all the best.